let's go back to parts per million. Question number 2. The concentration of potassium iodide is 150 parts per million. How many grams of potassium iodide is present in the solution? Wow, bongga. Okay. Now, question number 2, it's here in the top of my solution here. So we have parts per million again. Standard formula, grams of solute, which is the potassium iodide over the grams of solution times 10 to the 6, because this is our formula of parts per million. Now we get 150 parts per million. So let's say 150 parts per million. So grams of solute, it's our unknown. So grams of Ki, unknown. And then grams of solution, meron ba? How many grams of Ki is present in the solution? Okay? There's no value of the grams of the solution also. Okay? Like that. Times 10 to the 6. Ganon. So how can you attack this problem? Okay? You have the concentration and you don't know how many grams of potassium iodide present in the solution. It's unknown. How can you get this one? Okay? So, mga pamapakalangga, ang family mo aning gayo na. So, let's try to equate this first. Okay? Ang parts per million. So, parts per million, according to theory, okay? Apart from the standard formula, okay, let's say it's equal to micrograms, okay, over milliliter, okay, and then it's also equal to, nakakaloka, okay, we have milligrams per liter, okay, then we don't have any given, so if we try to compute for the molecular weight, what will appear is the gram per mole. And there's no connection also because we don't find the mole. You get the point, mga palangga. So in this case, what we're gonna assume? We're gonna assume a 100 gram of solution. Okay? Because it's not mentioned. You get the point, mga palangga. Okay? Muna siya yung itabo. You get the point? Okay? Then if you try to break also this potassium iodide into aqueous solution, because okay, this is oh my gosh, potassium iodide is equal to potassium positive plus iodide negative. Okay, so both of them have a positive 1 mole, 1 mole of potassium and 1 mole an iodide. Okay, ganon. Okay, so nanatay mole nga 1. Diba? Okay, so get the molecular weight, potassium. So this is really 39 point, ano sabi siya? 39.3? Okay, 39.3 mga palangga. 39.3 ang potassium. 39.3 gram per atom. Okay? And then iodine, so halogen family. Okay. Asa na itong mga fluoride, chloride, iodine, group 7A na siya, di ba? Oh yes. It's gonna be 126.9. 126.9 gram per atom. If you add all, it will become molecular weight per molar mass na gram per mole because already compound. Okay? Molar mass. I-add na mo siya because there's no subscript. 12, 10, 6. Okay? 12, 10, 6. 4, 6, 166.2. Wait mga kalangga. Okay. 166.2 grams per mole is the molar mass of potassium iodide. Okay. Now, you can relate that here to your formula. No, it's not because we need only the grams. Okay? But who knows, later we will connect that later. Okay? But let's assume that we have a 100 grams of solution. Okay? Ganon. Get the point mga palangga. Okay. Ganon. Okay, so naman tayo 150, we will say grams of potassium iodide is equal to, wait ha, times 10 to the 6 equals to 150 times 100. Then grams of Ki is equals to 150 times 100 divided by 10 to the 6. Okay? Napugusta because there's no other given. Okay? And this is not also a chemical reaction. This is only dissociation of potassium iodide in aqueous solution. Okay? Like that. So, it's gonna be 150, nakakaloka, 150 times 100, ganon, diba? Divided by 10 to the exponent 6. So 1.5 times 10 to the negative 3. It looks like it's very small, huh? 1.5 times 10 to the negative 3. That is grams. If you convert this to milligrams, pila. So, 10 to the negative 3. So 1.5 na sabi siya, 1.5 milligrams diretso. Okay? Like that. So 1.5 times 10 to the 3 grams is equal to 1.5 milligram. So this is our grams of potassium iodide is present in the solution. Okay? Because the solution is not mentioned. Okay? And there's no grams of the solution either being specified. And there's no density of the water. You get the point? And then if you try to compute for the grams per mole, then we cannot relate also. You get the point? So if you will say, like this, 1 mole of potassium iodide, and then equal to, atong balihon ni siya, so 166. Ato na yung try ang option guys ha, because you know guys, having a basis of calculation is the last option. Okay? We try all, we extract all possible data because it's only the last, the basis of calculation. Okay? So let's try. So if I have this dissociation reaction of potassium iodide into water, it will become potassium positive plus iodide negative. Now if we try also to log the number of moles each, our potassium iodide has a 1 mole. So 1 mole of potassium iodide related to the molecular weight or the molar mass. So it's gonna be 166.2 grams over mole. Okay, so we have now the grams of potassium iodide. Now, if that is the case, I have now the grams of potassium iodide. So what is the use for the formula of PPM? So, this is not really logical. Again, you have to say this. Nakakaloka. Diba? Nakakaloka. Okay, so I have 1662 gapon, 62.2 grams of potassium iodide. So I get immediately the grams of potassium iodide without considering the data of the question number 2, right? Which is 150 ppm. So what's the use of 150 ppm there? Then we get already the mass with the molar mass. It's gonna be, this is not valid or illogical. Okay, option number 2. Okay, we have now option number 1, option number 2. Option number 1, we can get directly 1.5 milligrams by using the basis of calculation based on our formula, because we have no other choice, 100 grams of solution. And then option number 2, we have 166.2 grams of potassium iodide by using the number of moles in the dissociation chemical reaction without considering the 150 ppm. And now, option number 3, we will use the 166.2 grams potassium iodide, and then we need to compute the grams of solution. And then later, we will come back to compute for the grams of solute. It's just because to incorporate the 150 ppm, and we will go back to compute for the grams of iodide, potassium iodide. It's also a little bit logical. Let's check. Okay, possible. I-extract nyo na ito ang mga options to get the correct answer. Okay, because this is on the spot mga kalangga. Okay, now we have we have grams of potassium iodide. Okay, parts per million itong unahon, 150 naman ta. Okay, and then nakakuha na tag 166.2 based on the, dissociation balancing of our moles. Okay? 60 grams, ganon. And then, our grams of solution is unknown. Right? Because we don't have ground solution in our problem, and we have to find out that one. Okay? Let's check. If you can also have 1.5 milligram answer, then bingo, it's correct. Okay, so gram of solution will be by math, algebra. Okay, so 10 to the 6 times 166.2 is equals to divided by, wala nakakaloka. Okay, diba? Okay, mga palangga, ano siya? Taas kayo siya, guys. Okay, so 166.2 kay exponent mega number siya. So sige lang, kung ikabutan na ito na mawala ng mega. Charot! Diba? Times 166.2 is equals to divided by 150. So now, na natin yung mga kuan palangga. So, kung saan ba siya? 11 million. Paano na lang ito? Exponential. 1, 2, 3, 4, 5, 6, 7. 1.11 times 10 to the 7, right? Yes. 1.11 times 10 to the 7 grams of solution pa niya mga palangga. Okay. Now, grams of solution. I-convert din mo siya of milligrams later, but take note na lang later na lang siya. Charot! Okay? Ganon. Now, okay, going back to the very basic in solution. Grams of, let's assume this is water because it's not mentioned walang solvent kasi. Normally, if not mentioned, that is water. Okay, pag solution. Okay, so gram water plus gram of, potassium iodide. Why? Because it will never dissociate without addition of water or any other solvents. And do we assume water? Because there's no other solvent mentioned in the problem, which is the standard in solving chemistry problems. Okay? Like that. Now, we need to solve for the grams of, the grams of solution. Ano naman mga palangga? No. So, grams of water is equal to the grams of solution. Ako na compute 1.11 times 10 to the 7 grams minus the grams of potassium iodide na mauli siya 1.66.2 grams. 166.2 grams. What is the gram of water? Charot. Okay. Grams of water. Okay. So, muna siya natabo mga palangga. So, 1.11 exponent to the 7 minus 166.2. So, our grams of water is 1.1, 2, 3, 4, 5, 6, 7. 1 point, siguro lang kayo siya, kasi point something lang wood siya. Okay, so 1.10 times 10 to the ganon. Okay? So, since gamay natin siya difference siya, guys, it doesn't matter. Okay? So, okay, it doesn't matter. Okay, gamay natin siya difference siya. Okay, ibalik na po na ito sa grams of solute. Right? Ibalik namin gapon siya sa 166.2. So, hindi siya ma-validate ang 166.2. Okay? So, our answer really is 1.5 milligrams or 1.5 times 10 to the negative 3. Okay, mga palangga? You get the point? Okay? So, muna siya answer sa atong question number 2. 1.5 milligrams. Okay? So, it's not possible to use the other method. Okay? Like that. Okay, question number 3 na task. Thank you so much for watching this problem number 2. Okay. Now we go to problem number 3. Okay, may time pa ba mga palangga? Okay. Okay. So, problem number 3. Okay. The concentration of nakakaloka. Sodium phosphate is 400 ppb. Oh, this is parts per billion. Nagkadakot ng mga palangga. We go higher and higher. This is parts per billion, not the parts per million. So, in what's this? Okay. The concentration of sodium phosphate is 400 ppb in a 500 milliliter of solution with a density of 1.02 grams per ml. Wow, bongga. How many micrograms, nakakalola yung question. How many micrograms of, ba ito talaga, of sodium phosphate is present in the solution? Ha? Piga-piga. Okay? This is not a simple conversion na talaga because 10 to the 9, ganon. Okay? So, okay. Now, write the data. Okay. We have sodium phosphate. Identify what is sodium phosphate, what is a characteristic of a sodium phosphate. So this is a salt because phosphate is a salt. Just like where sulfate, phosphate, like that. Okay, what else? Mga palangga, carbonates, right? And sodium hydroxide family. So these are bases, right? Okay. So